This week we are covering real-time operating systems, or RTOS, and imagine that you want a monitoring device that continuously processes samples from an ADC connected to a sensor and performs some DSP or signal processing on those samples. And then you also have, it has a simple user interface with some display and some buttons, and you also have an Ethernet interface to communicate data on a network. The main question is, how would you implement this? Well, if you use the pooling method, this is probably going to have a main super loop and will be a complex super loop and probably not that responsive. We know that the pooling method, when the applications are complex, this is not a good approach. Another method is to start doing things on your interrupt routine. So you start putting all your code inside of interrupt routines, which again, it's not too responsive because you are going to spend long periods inside of those interrupt handlers, and that's not a good idea. And this is when we have our third way of doing things, where you combine the pooling with and interrupts. But even this one suffers the same problem as the pooling method. It's not going to be that responsive because you're doing a lot of code inside of this process A, B, and C. So how do you handle a situation like this when you're developing embedded systems? Well, this is when you have multitasking systems solution. So you're using an operating system. So you're going to divide your requirements into tasks, making each task relatively simple to implement. And then the interrupt processing is kept to a minimum, and the scheduler determines which task is going to execute. So in this example, if you have the ADC, the buttons, and the Ethernet, what a scheduler is going to do is you're going to define a certain amount of time for task 1, and if task 1 doesn't finish during that time, it's okay, moves for task number 2, same thing happens to task number 2, then goes to task number 3, and it starts going on this round-robin fashion. There are different types of schedulers. This is just showing a round-robin one. And with these, you can give priorities to tasks. So if ADC or task number 1 is higher priority than task 2, if you need to attend that task, you can just stop this one and go back. So you can play around with these, similar to interrupt routines, but at the application layer or level. There is a difference between OS and RTOS. So RTOS stands for Real-Time Operating Systems, and RTOSs are architected to ensure that every application, every service, every message, and every task and threads are handled in a way that guarantees prompt, consistent, and assured execution, a concept known as deterministic. With RTOS, the most important stuff gets done within a rigorously defined timetable every single time. There are two flavors of RTOS. You have hard real-time operating systems or soft real-time operating systems, and the difference is stated here in these statements here. Hard real-time is designed to guarantee that the responses deadlines are always met. So if I miss a deadline, it's considered a total system failure, so an electronic engine or a flight control. And a soft real-time is optimized to meet responses deadlines. Missing a deadline results in incremental degradation, which can result in system failure if deadlines are repeatedly missed, but you can kind of tolerate that. So a user interface or interfacing video, for example. Normally, if you have an ability, if your RTOS has the ability of doing hard real-time, you can do soft real-time applications, but the vice versa is not true. If you can only do soft real-time, you're going to have a hard time to do hard real-time tasks. For this week, we're going to use the free RTOS, and I'm providing a link, and you can go over the answers of these questions over here to learn a little bit more about what is an RTOS, what is a kernel, what is a scheduler, and how to use, and I'll get started with this free RTOS. And I'm providing a link also from free RTOS where they go over real-time application design tutorials. So they have this system over here that has a terminal, some communication modules, some LEDs and LCDs, and how can you start designing and shaping your application using free RTOS. It's a pretty cool example. And then some additional reading material if you end up to follow these embedded systems tracks for your professional life. These two books, they're pretty much similar. They're the same author here. This is a fourth edition, has a little bit more content than the third, and also the third has things that the fourth does not have. Pretty good books, and they can complement all the stuff that we're learning about real-time operating systems or embedded systems design.